So welcome back to chapter 3. We're going to continue with the third objective. So I've got the data still up here at the beginning. We're going to continue with the third objective and looking at measures of dispersion. Now, I'll tell you I've decided, and you can give me your feedback from this when you watch the video, that I'm going to do the Excel part in a separate video instead of kind of flip-flopping back and forth. So we're going to look at, in this objective, some measures of dispersion. So that's looking at how variable the data is, right? So kind of how, think about when we were graphing it on a scatter plot. Do all of the points kind of line up in a nice neat line, or are they kind of all over the place? So that's sort of what we're looking at today. So the first one that we're going to look at is the range. The range is the easiest. It's just the maximum minus the minimum. So it's the easiest to calculate. So if we look at our data, when we look at the growth fund, we're going to take the maximum return of 36.29% minus the minimum return of 38.32%. And we see that we have a range of 74.61%. And then the same thing for the value. Remember, when you're subtracting a negative, then we end up adding these two numbers together. Now, the mean absolute value deviation. So this one, I want you to try to listen to me explain it, and then we'll look at the formula. So think of if we had plotted all of these points, and then we calculated the mean. So we're going to calculate the difference, the absolute value of the difference between each point and the mean. So we're going to calculate the difference between each point and the mean, and we're going to take the absolute value, which means we make it positive, and then we're going to average those differences. So again, this will tell us how varied the data is. If the data all kind of lines up in a nice neat row, then our mean absolute value deviation will be a relatively small number. The more varied the larger the number is. So if we're comparing two different data sets, we'll be able to look at those and see kind of how varied they are. So for the sample mean absolute value deviation, we're going to take the sum. Remember, this funky E is our Greek letter sigma of the absolute value. So remember, these bars right here mean absolute value of the observation. So xi is whatever your observation is, minus x bar, which remember is the sample mean. And then we divide it by n, which is the sample population. So we're going to take the differences, take the absolute value, add them all up, divide by the sample size. If we're going to do the population mean, it's the exact same thing, except the population mean absolute value deviation, except remember, we're going to divide by the population size, not the sample size. Now we're going to look at calculating this in Excel, but let's walk through how we calculate it by hand, just so we have that kind of fundamental knowledge. So if we're looking at the growth fund, the first thing we're going to do is take the observation. So the first observation that we have is a return of 12.56. We already know that our mean is 10.09 because we calculated that in the first video. So the difference between the observation and the mean is 2.47, and then take the absolute value is again 2.47. So if we look at the second observation, or a second observation, they just don't have to be in order, it's a negative 38.32. So we're going to take that observation minus the mean, gives us a negative 48.41. But because we want the absolute value, we're going to turn that into a positive number. So we'll do that for all 10 of our observations. We'll subtract each one from the mean, or subtract the mean from each one, take the absolute value, add them all up, and we get 135.6. So we've added all 10 observations up, we get 135.6. We'll divide that by the sample size of 10 to calculate that mean absolute value deviation of 13.56. And we'll see that when we get to the Excel in the next video. So another way that we look at the variance and we look at the dispersion is by calculating the variance and the standard deviation. Now we're going to calculate these over and over and over throughout the course, so it's important that you kind of get these and understand. So the first formula that you see here is calculating the variance. And again, the variance is looking at how clustered around the mean the observations are. So if the observations are all very close to the mean, or a lot of them are close to the mean, then we'll have a very small variance. As they are more spread out from the mean, then we'll have a larger variance. So you notice that the formula for the variance is similar to the mean absolute value deviation in that we're going to, in the numerator, take each observation and subtract it from the mean. But then instead of taking the absolute value, we're going to square it. And then we'll sum the squares. So again, we're going to come back to this in a slight deviation of this when we get to linear regression in a later chapter. So this is something we use a lot. So then we sum the squares of the difference from the mean and divide it by n, which is again the sample size minus 1. So that gives us the variance. So then to calculate the standard deviation, we have to calculate the square root. So this is the standard deviation. And so we take the square root of the variance to get the standard deviation. So for the population mean, it's very similar. Now, I want to point something out. This funky looking letter right here is the Greek letter sigma. Now, yes, that backwards E is also the Greek letter sigma. This is the uppercase sigma. Excuse me, this is the lowercase sigma, and the backwards looking E is the uppercase sigma. So the backwards looking E is sigma, but it means sum. This lowercase sigma, this kind of O with a hook at the top, is the lowercase sigma, and it means the population variance. So the population variance, notice the numerator is exactly the same. It's just that the denominator is the population size. And then again, we'll calculate the standard deviation by taking the variance of the population and taking the square root of that. So again, this is really important. So if you're thinking about kind of that normal distribution, that kind of bell curve, which we'll talk about more in a later chapter, the closer to the mean that things are, then what we're saying, what it turns out to happen is that about 95% of all observations fall within 2 standard deviations of the mean. So only about 5% of observations in most populations and most samples fall in the tails. Okay, so we're looking at, again, how spread out, how varied the data is in comparison to the mean. So let's look at the data from the growth fund and we'll calculate the variance and the standard deviation. So again, we've got all of our observations. On the left, we're going to take our observation minus our mean. Remember, we already know what our mean is. It's 10.09. We know that from the first video when we calculated that. Now, instead of taking the absolute value like we did when we were calculating the mean absolute value deviation, we're going to square each mean. So for our first observation was 12.56% return in 2007. Minus the mean of 10.09 gives us 2.47. When we square that, we get 6.10. We're going to do that all the way down for each of the 10 observations and then total that up. So this total here becomes the numerator in our variance calculation. So now we're going to take that numerator, divide it by the sample size minus 1. And so that gives us a variance of 418.10%. Now to calculate the standard deviation, we'll just take the square root of that 418 and we get 20.45%. So that means that even though our mean is 10.09% return, on average, the observations will vary by about 20%. Plus or minus, so those goes both ways. They can go up to 30, they can go down to a -10. Obviously, we have observations that go on the extreme of that, but remember about 95% of the observations fall within 2 standard deviations. So this is kind of 1 standard deviation away from this. So the coefficient of variation is again another way to measure dispersion. We're just going to take the standard deviation and divide it by the mean. Now, why we want to do this as opposed to just looking at the standard deviation is if I'm comparing 2 different samples and let's say they have very different means, then when I start to compare those standard deviations, everything's going to be a little bit off because their means are different. If the means are close together, then it doesn't matter so much. But if the means are different, if we have a mean of 2.4 and a mean of 200, then we really can't compare those. So by taking the coefficient of variation, it allows us to compare those. So now we can compare 2 different samples or even 2 different populations standard deviations. So to calculate, it's real easy. Once you have the standard deviation for the sample or for the population, you just divide by the mean, divide by x bar. So we're going to do that for both the growth fund and the value fund. So we've already calculated the standard deviation for the growth fund. We know that that's at 18.46%. And if we divide it by the mean of 10.09%, we get 2.03. If we look at the value fund, when we take the standard deviation, and we didn't calculate this one here, but we'll do it when we do the Excel, and divide it by x bar, or the mean of that sample, we get 2.44. So we can tell from this that even though the means are different, it looked like originally the growth fund had more variation because it had a standard deviation of 20.45%, and the value fund had a standard deviation of 18.45%. But now when we adjust for the difference in means, we see that the growth really has less variation. It's really only a 2.03 coefficient, where the value is a 2.44. Now, we looked at this at the end of video 1, but I just wanted to pull it back up here, pardon me, for you, add it back in. These are some of the formulas that we're going to look at when we get to the Excel video so that we can calculate these different things that we've just talked about here.